We start? Okay. Good morning, everyone. Today I will just tell you a little bit about the second topic, the second of my topics. It's also with time series in GRASS GIS, but I will show you some applications for disease ecology and also the connection between GRASS GIS and R. So you already know me. I don't present myself again. So this connection between GRASS, GIS, and R is done by this package, RGRASS 7, developed by Roger. And this package has a series of functions. For example, with init-GRASS, we start GRASS from R. And then with exec-GRASS, we just call different GRASS functionalities. So it's basically like a wrapper to call GRASS GIS functionalities within R. Then with readback and readrast, we read data that we have in our GRASS database into R. And in this case, for vector, we have already support for simple feature objects. And for raster, it's still SP objects, but there's a plan to get support for stars object, right? And then with write-back and write-rast, we just export. After doing our analysis in R, we can export our vectors and rasters again to the GRASS database. So I will show you during the workshop some analysis with the temporal framework in GRASS GIS, and then we will move into R and do some modeling there, do some species distribution modeling, and then write back our results into GRASS. And so with that, we just like close the circle. Yeah, well, I just wrote the link. I think I prepared this presentation just before the new package was out, and so there's the link still. And, okay, those of you that were already in the introduction to GRASS GIS or also yesterday in the first topic, know that we can use GRASS and R together in two different ways. So one of them is using R within GRASS. So within a GRASS session in the terminal, we can just type R, and we get R inside, and the sessions get connected. So we just load the RGRASS 7 library, and then we are there, and we can read our data and then write back, do our processing, plotting, analysis, and write back. And the other way is using GRASS within an R session or R studio session. So we just do not start GRASS at all, but we start it from within R studio or R. So there are commands, this one, the init-GRASS command. With this one, we can start GRASS from R. Now, how is the procedure in each case? When we use R within a GRASS GIS session, meaning that we start R from GRASS terminal, we do not need to use this init-GRASS. We just type R in the terminal or R studio, and then we get the new program, new software there. And we access all the functionalities with exec-GRASS. We just read our data in from the GRASS data. We do our processings and analysis and plotting, everything we want to do. And then, if needed, optionally, we can write the data back. So it's actually pretty simple. And the other way is was more thought to just use with your data. So let's say you are not a GRASS user, maybe most of you, but you still need to use some GRASS GIS functionalities because, I don't know, for whatever reason it works fine, or you were told it worked better. So you don't need to go through all the steps of importing your data into the GRASS data, understanding the locations and the map sets and such. But you just initialize GRASS from R with this init GRASS, and you create like a throwaway location. So it's like a temporary location, just to put your data there and then use GRASS functionalities. And then when you close the session, that location will be thrown away. Okay, so it's just, if you are not a GRASS user and you want just to use some functionalities from R. Yeah, that's it. Then I leave you here some other links for more detailed examples. There's an R and GRASS presentation I also did in a course I taught in Argentina. And there's an example also for GRASS and R for raster time series in the wiki. So you can have a look of the workflow. And there's not only RGRASS 7 as to link R with GRASS or other GIS, but there's also this package that I only got to know last year in Prague, in the Geostat last year, linked to GI. And I left you there the link because it's also pretty nice. And it's like system calls. So you set, again, some parameters to call GRASS to say where the binaries are, where the location and map set and such. And then with system calls, you just call the commands from GRASS, for example, but also with Saga, and there's also a package to connect with QGIS. So there are many links between GRASS and GIS systems. Now, what will we do during the session? We will work with data from an invasive mosquito species in northern Italy. So first, we will use an add-on to import data from this global database of species records. We will then create background points that we need for the species distribution modeling. And then using the temporal framework of GRASS GIS, we will add a daily time series of LST. So remember, insects are ectotherms, and so they depend on temperature for all their life stages. And then that's why we are using LST. We don't have air temperature, we have surface temperature. So we're using this daily LST to estimate growing degree days, for example, or all the bioclimatic variables based on temperature, but with data matching the time period for which we get the occurrences. So instead of using WorldClim or BioClim data that is like from 1950 to 2000, we just use more like nowadays data that matches the period, okay? Well, and we will estimate like different variables like that. We will use the temporal algebra to estimate, for example, the number of consecutive days with more than 33 degrees, because after that, then the larvae die, for example, or the number of days with temperatures between 20 and 30, because that's like the optimum for mosquito development and virus transmission, and things like that, like the length of the mosquito growing season and such. After that, we will just move to R. We will connect our sessions and import both the vector data and the raster data, and we will use Maxent or random forest, can also be, to model the species distribution, this mosquito species distribution. Then we will go through model evaluation and visualization of results. Well, for more details about the temporal, so I won't go through the same part that I told you yesterday about the temporal stuff, because that's supposed to be done. We will just start with the Handson. And this is the mosquito, the Aedes albopictus species. It's an Asian tiger mosquito in northern Italy. So we will get data directly from internet, occurrences of this mosquito in a certain time period. And then we will use this MODIS LST reconstructed, kindly provided by Mundialis, and it's based on a paper in which we reconstructed the full MODIS LST archive, so the 4 overpasses per day. This is just an average temperature per day, but indeed MODIS has 4 overpasses. The resolution is 1 kilometer, and it's been already converted to Celsius degrees. So if you please will take the session, please start downloading this location. It's a ready-to-use location because it's like 1 giga. And so maybe you want to start now. And here's also the GRASS script we will use and the R script. So if you plan to attend, just maybe you can start downloading. So once we are there, we just start with the Handson. Yep, let's start GRASS. Thank you.